and he's friends with Bill Nye. He's got his own crew, and he's here on YouTube.
All right, this is question number 29 about the mass of a pulley. I think later on I talk about it being question number 30, but make sure you're working on question number 29. Okay, now this is the problem that has the frictionless pulley. Okay, we have two masses. One is a 2 kilogram mass, and the other one's a 6 kilogram mass. I'm going to put those onto the pulley, and we're going to see which way they go. Now, Larson, since you've already probably done this experiment by playing with my pulleys back there, you could probably answer this for me. But I'm guessing the rest of you could probably, just from experience, tell me what's going to go on with this experiment. Okay, if I put a 2 kilogram on one side and a 6 kilogram on the other, we all know it's going to go towards the 6 kilogram side, correct? Correct. Okay, but I need to know exactly how fast they accelerate. So that's what we're going to figure out today. Okay, this 2 kilogram mass. Forget the pulley. We know that it's being accelerated on by gravity. And so that means my acceleration is going to be downwards at 9.8 meters per second squared. Okay, that can give me my force. So 9.8 times my 2 is going to give me a force of 19.6 newtons going downwards. Okay. Now on the other side, I have got 6 kilograms going downwards. Okay. Also being accelerated on by gravity. So 9.8 meters per second squared. Okay. If I take 6 times 9.8, it gives me a number of 58.8. And that's going to be newtons. Okay. So on one side I have a force of 58.8 newtons. The other side I've got 19.6 newtons. Okay. Tug of war. Which one's going to win? The 58.8 newtons. Okay, how much does it win by? We'll do the level of math on this. 58.8 minus 19.6 newtons. Alright, so what does that give me? I have to do the math on easy subtraction here. 39.2 newtons. Okay. Now, that's not what it's asking though. Your question asks you, this is number 30 by the way, your question asks you, what does it accelerate at? Okay, some of you might just be figuring out how much the 6 kilogram accelerates at. But now you have a system, they're tied together. So what we have to figure out is how much does the whole system accelerate at. And so I go back to my old equation of F equals ma. My force is 39.2 newtons. Now my mass of my system is not 6. My mass of my system is 8 kilograms times my acceleration. Okay, so this will tell me how fast or how my rate of velocity going downwards. Okay, so I take that, 39.2 divided by 8, and that gives me my answer of my acceleration is 4.9 meters per second squared. Okay, hope this helps you out. The next problem we're going to be working on is going to be over elevators. We'll see you tomorrow. Back with elevators. Now I'm going to be dealing more with concepts here instead of a lot of mathematics, but just kind of give you some ideas of what's going on. Okay, I hope we've all been in an elevator at least at one point in our life. We kind of have that experience, those life skills of what's going on. You climb into an elevator goes up, what happens to your body? You feel that initial ugh, and it feels like you're getting tugged down. Okay, your body's getting heavier because what's happening is you're accelerating. You're having to go past the gravity to get the elevator to move upwards. So we're actually fighting gravity, that 9.8 meters per second, to get us up and going. Now, once we get to a certain point, once we get that initial overcoming of gravity, the elevator is going to move at a constant speed. Okay, now we know about constant speed and constant velocity is we're not applying a force. If we're not applying a force, that means that we're not accelerating. That means that we can be continuing back to our normal weight force. Now, as the elevator goes up, 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 eventually it starts to slow down. It's going to reach its floor and slow down. And when that happens, what happens is your body starts to feel lighter, lighter, lighter. It's because you're not being pushed down on by gravity once again as much, because the elevator is actually kind of falling beneath you. You're traveling at the 9.8 meters per second, or what's above, and now the elevator starts to slow down. So actually what happens to your weight force at that point is it drops. So if we stuck a scale in the elevator, you ride the scale, you would literally see as you're going upwards, the scale get heavy, and as you reach your destination, you get lighter. Okay? Same thing can be said for when you go down. When you first starts to go down and it drops out really quick, you feel really light. And as you hit your floor, you get heavier. Hope this will help you out a little bit with your problem, at least the concept of what's going on with your problem. We'll see you tomorrow.